Okay, so today's session I am going over the square root property, which is covered in section 9.1. So the square root property says that for any real number k, and when we say real number, it can be positive, it can be negative, it can be decimals, just any number. If x squared equals k, then x equals plus or minus the square root of k. So there's some notation here that I need to explain. So we read this as plus or minus, and the plus or minus sign indicates two possibilities, positive and negative. So an example is if you see plus or minus 2, that is the same as saying you have positive 2 and negative 2. And you can have more complicated things after the plus or minus, but it's basically telling you that there are two things. And we use it as a shorthand. It just kind of saves some space when we are doing math, where basically all the steps are the same. The only difference is a plus or a minus in that one spot. So you'll see a lot more when we do the quadratic formula, but that's what this symbol means. So basically what this is saying, this is if you have some equation x squared equals k, it's basically saying that you are allowed to take the square root of both sides. And a square root cancels out a square, which is how we're left with x. And then when you take square roots and you have quadratic values and you're looking for x, you get two possible answers, the positive or the negative version of whatever that number is. And so then you can write the solution set as plus or minus square root of k, or you can write it in curly braces as square root of k and negative square root of k. So this is just a technique for solving that says that you can take the square root of both sides. And we get two values for the square root when we're solving. If you're taking the square root and you are not solving for x, if there's no variables involved, then we assume the positive. But if there are variables, then we have both answers. So I'm going to just make a note here. So if variables are involved, the square root has plus or minus in front. Because we could have two possible answers that fit in this equation. So an example, let's see, we know that if you square 2, that gives you 4. But if you square negative 2, you also get 4. So if somebody was saying, okay, if I have some number x squared and that equals 4, the values that work for x can be 2 and negative 2. Oops, did not mean to switch that slide, go back. Okay. So because both 2 and negative 2 work, that's why we say we have a plus or minus square root of 4, and the square root of 4 is 2, so it's plus or minus 2. So your answers are 2 and negative 2. So that's why there are two answers, basically, is because when you square these numbers, the negative will cancel out, you're left with, you get the same answer. So there's two choices that can work in for x. And that's why we only do this when we have variables, because if there's no variables, then there isn't two choices, there's just the one. So I'm not sure why, for some reason, these were supposed to say example, and they apparently have disappeared here. Text is not there. We're going to solve the equations here, and we've got two different possibilities using the square root property. So I'm going to just rewrite these, and then I'm going to use the square root property in a different color. So the square root property just says that we are going to take the square root of both sides. So I indicate that in another number or a different color to show that I'm taking the square root. and the square root and the square cancel. And that's something that we covered in 8.1 and 8.2 where you're learning about square roots. And then the square root is 16, so we're going to have plus or minus, and then square root is 16 there. So I like to write that step first to make sure I have the plus or minus. Then I simplify the square root of 16, which is 4. So our solutions are 4 and -4 because of the plus or minus there. If you square both of those and you make sure you have the -4 in parentheses and you square them, you will end up with 16. And this works even if you don't have x. So here we have k squared equals 100. So again, I'm going to just rewrite this. So we start taking the square root of both sides. So that cancels out the square. We're left with k, and then we get plus or minus the square root of 100. And the square root of 100 is 10, so we get plus or minus 10. So if you don't want to do like k equals, you can also just use the set notation. And we write our answers as 10 and -10, because we get the positive version and the negative version. And once again, I think all of these, for some reason, it didn't show up. So here's a different example. It's slightly different. Solve m squared minus 64 equals 0 by both factoring and using the square root property. So some of these problems can be solved either way. So we will start by factoring, and then we will have the square root property. So m squared minus 64 equals 0. So this is a difference of two squares. That was one of the special products that we learned about. And that says that if you have something like a squared minus b squared, that's a minus b times a plus b when you factor. So you're looking at what things are squared. So we've got this m squared, so that's going to be basically a, but 64 is a perfect square. So if you want, 64 is 8 squared, so you can rewrite that as 8 squared so that you can see how it fits into our difference of two squares formula. So that means a is m and b is 8. So this will give us m minus 8 times m plus 8 equals 0. So when we solve by factoring, once you've done the factoring, then you set each factor equal to 0. So we have m minus 8 equals 0 and m plus 8 equals 0. And then we solve for m. So the first equation, I'm going to add 8 to both sides. And on the second equation, you end up subtracting 8 from both sides. So our first solution is m equals 8, and the second solution is m equals -8. So if you want to put that in set notation, you can write 8 and -8. So now let's solve this with the square root property. So we have m squared minus 64 equals 0. So the square root property says that if you have like x squared equals k, then x is equal to plus or minus the square root of k. So we have to put our equation into the form where we have something squared equals a number. So I have my m squared. I want to get that by itself. So I need to move the number to the other side. So I'm going to add 64 to both sides. That gives us m squared equals 64. So now we are in the right form to use the square root property. And so we will take the square root of both sides. So I'm going to write that in. So the square root and the square cancel out, so we're left with n. And then we get a plus or minus square root of 64. And the square root of 64 is 8. So we have m equals plus or minus 8, which gives us our positive 8 and our negative 8. So you see you get the same answer with each method. So a problem like this, you can choose which method that you use. I usually use the square root property because I find it easier. I find it a little faster. You can see the number of steps are roughly the same, but I feel like it's a little easier to work with. So if I have a choice, if I can use the square root property, I will do so. Okay, next example. Solve the equations using the square root property. So again, we're going to be squaring these, but taking the square root, but these are going to be different. So first we have q squared equals negative 50. So I'm going to just rewrite it. So we have q squared equals negative 50. So when you solve this, you're going to take the square root of both sides. And we get q equals, and now we've got a problem here because we have a square root of a negative. If you try to take the square root of negative on your calculator, you will get an error. That's what most calculators give when you try to do that. Mine says domain error. So I'm going to just kind of indicate this. Square root of a negative equals an error, and that's because it's not a real number. If you take the square root of negative, you actually end up with something called imaginary numbers, which you will learn about in college algebra. So it is not considered a real number. Sometimes you'll see errors like you'll get something like depending on your calculator or something like that. So if you get an error, we don't have a real number solution for this. So the way that we will indicate this is we will say there are no real solutions. Sometimes you'll see it written with an empty set, where you're using the set notation, but you're not putting anything inside. Sometimes you can see it with as like a big O with a line through it. So that is another symbol for the empty set. But there's no real solutions because you get error. So you want to be careful when you're doing the square root property, because sometimes you get things that don't actually work out. So now let's take a look at the second example. We have 4v squared minus 24 equals 0. To use the square root property, we want to get the v squared by itself. So we want to isolate this v squared. So it's like you're solving for v, but we're solving for v squared instead. But the steps are very similar. So I'm going to start by adding 24 to both sides. So I'm left with 4v squared equals 24. So now I want that v squared. I'm trying to isolate this v squared, so I need to get rid of the 4 in front. And so we do that by dividing both sides by 4. So we're doing the same steps that we would do if we were solving for v. We're not doing anything different so far. So this gives us v squared, then 24 divided by 4 is 6. Now, this is where your steps differ, because now we have v squared, not v. So now we're going to use the square root property by taking the square root of both sides. So we have the square root of a square that cancels. We're left with v, and we get plus or minus the square root of 6. So square root of 6, if you do that on your calculator, that gets a decimal. So we generally don't write the decimal form. We want to try to simplify the square root if possible. and 6 is 2 times 3, neither of which you can take the square root of. So you can't actually simplify the square root. But if it's a bigger number, like maybe you get 8, you can simplify the square root, and then you have to use the techniques from 8.1 and 8.2. In this case, we can't, so our solution is the square root of 6 and negative square root of 6 because of that plus or minus. Okay, so now these are going to be my last two examples, and they show how you can use this technique when you have things that look a little more complicated, but the steps are essentially the same. So on the left here, we have b plus 3 squared equals 1. So we don't have like b squared equals 1. We have b plus 3, but we still have something squared equals a number. And that's the idea of the square root property, is that you have something squared equals a number. And so then you take square root of both sides, and you get whatever that something is equal to plus or minus the square root of the number. So even though it's not b squared, it's b plus 3, it's still in the right form, and so we can still take the square root of both sides. So that square root cancels with the square, and then we're left with b plus 3. So instead of being left with just b, we have b plus 3, and then we have plus or minus the square root of. Now the square root of 1 is equal to 1, so we get b plus 3 equals 1. Whoops, I forgot my plus or minus. Plus or minus 1. So now we need to subtract 3 from both sides, but we have an issue because of the plus or minus. You're not allowed to add or subtract to something that has a plus or minus. You have to write it in its two separate forms before you can do that. So I have to write two separate equations here in order to continue solving. One of them with the plus and one of them with the minus, because I cannot add or subtract to things with a plus or minus. So I've separated that out. So I have b plus 3 equals 1 and b plus 3 equals negative 1. So for the first equation, I'm going to subtract 3 from sides. And you'll see in the second equation, we are also subtracting 3 from both sides. But the values we get are going to be different. So our first answer is 1 minus 3, which is negative 2. And the second answer is negative 1 minus 3, which is negative 4. So every example we've done so far has ended up with basically the same number example. In this case, that did not happen. So we have two answers. One of them is negative 2, and the other is negative 4. So you don't get a positive and a negative version of the same number. We actually ended up with two different numbers. So now let's look at, we have x minus 5 squared minus 3 equals 18. So first step is we need to get the squared part by itself. We need to have that something squared equals a number. So we're going to add 3 to both sides. This gives me x minus 5 squared equals 21. So now I have something squared equals a number, so I'm going to take the square root of both sides. That cancels out my square, so I'm left with x minus 5. And then I have plus or minus square root of 21. So 21 is, when you take the square root, you get a decimal. And 21 is times 3, neither of which number you can take the square root of, so we can't actually simplify that one further. And If you need more details on simplifying square roots, go back to 8.1 and 8.2. So here, we can't simplify the square root of 23, or square root of 21, I don't know why I said 23, square root of 21. And we want to get x, so we'd have to add 5 to both sides, but we can't do that until we've basically split it up into two separate equations. So we have x minus 5 equals the square root of 21, and x minus 5 equals negative square root of 21. So we're solving for x, so we're going to add 5 to both sides. And now 5 is not like terms with a square root, so we can't actually write those together. And so we actually write them as they are literally, sort of like we did the literal equations. We usually put the whole number first. So I'm going to write 5 plus the square root of 21. And then our second answer is 5 minus the square root of 21. Because we can't actually add these together because they are not like terms. Now, often we'll get lazy and just write 5 plus or minus square root of 21 because they can't be added. We did not do that with the example on the left because we can simplify further. But if you know you're going to be adding a number, subtracting a number to a square root, and they can't be combined, it's perfectly fine to kind of leave it in the plus or minus form because it's just a little short. It's shorter. And you'll see when we do quadratic equations, we'll leave it in the plus or minus form if square roots are involved. And if they don't, simplify to whole numbers. So let me turn on my video. There we go. So that is it. That is basically the square root property. It's actually a very handy property. I just heard a bang. I don't know what's going on. It's a very handy property. We'll be using it basically. You're using the idea of it for the quadratic equation. It's really nice when you're trying to solve things with, if you're trying to find, if you have a square and you know the area and you need to find the length of a side, you're actually using this a lot. This often is used with the Pythagorean theorem as well. If you've done things with the Pythagorean theorem, you're using this property. So probably you might have used it and you didn't even realize it. And usually in real life, the negative answer kind of gets thrown out because it doesn't make sense in context. And we assume the positive answer, but it's good to understand that there are two different answers. So that's it. I hope you guys enjoyed, and I will talk to you later.